Text-to-image AI is now a mandatory tool for digital workflows, but integrating it means facing a paralyzing choice between two highly polarized systems. Inside OpenAI's tightly managed ecosystem, you type a prompt into ChatGPT, and a polished image appears moments later. This is DALL-E 3, acting as a rented artist within a strict corporate framework. On the other side is Stable Diffusion by Stability AI. It is an open-source architecture that runs on your own hardware, essentially forcing you to build your own digital studio from scratch. The dilemma comes down to this. Do you pay a monthly subscription for effortless, beautiful results? Or do you take on a steep technical learning curve to guarantee absolute control and offline ownership? We are not evaluating which model generates a prettier sunset. We are analyzing how these tools actually function in a real production environment. If you choose the wrong model, you will either bleed subscription fees for features you outgrow, or you will waste a weekend trying to install software your computer cannot even run. You have to match the tool to your exact constraints. The sharpest divide between these two tools is how you issue commands. With DALL-E 3, inputting a prompt feels like texting a colleague. You type natural, conversational sentences directly into the ChatGPT interface. Behind the scenes, the AI infers your intent. It acts as an active translator, taking a simple request and padding it with lighting cues, camera angles, and stylistic details before it ever renders the image. The trade-off for this convenience is that DALL-E is an aggressive translator. It frequently overwrites your specific instructions to force the image into its own aesthetic guidelines, stripping away your pixel-level control. Stable Diffusion handles instructions with specific syntax. You assign mathematical weights to elements you want and explicitly list negative prompts. Bypassing the translator, these precise instructions route directly into the generation process. If you increase a color's weight, the model responds exactly to that math. But removing the AI assistant means you face intense trial and error. Getting a coherent image, especially when you need exact spatial relationships between multiple objects, takes deep experimentation. DALL-E prioritizes convenience and heavily relies on its own interpretation to ensure a usable result. Stable Diffusion demands you learn a mechanical vocabulary in exchange for raw, unfiltered control. Generating the initial image is just the first step. The true test of operational fit is how you edit that output. DALL-E includes a native in-painting feature. You simply drag a digital brush over a missing or unwanted element, type a quick correction, and the system patches it. However, you cannot force specific poses or map the physical edges of your subjects. The final edit is still entirely at the mercy of the model's randomized generation process. Stable Diffusion's advanced spatial control, powered by ControlNet, allows you to place a rigid human stick figure framework inside your canvas. With that framework locked in, the AI perfectly matches the pose, generating an astronaut, a knight, or a robot around the exact same bone structure. To utilize this exact spatial control, you have to source reference materials, download massive secondary model files, and operate advanced node-based interfaces. DALL-E is sufficient if you just need to casually replace a tree in the background. But if your project requires exact spatial consistency and skeletal posing, Stable Diffusion is mandatory. Neither of these platforms is truly free. They just extract different types of costs from the user. Accessing DALL-E 3 requires a $20 monthly subscription for ChatGPT Plus or incurring per-image fees through their API. The massive operational benefit here is that OpenAI provides the hardware. You can run high-end image generation entirely in the cloud, using a standard laptop or a phone. The hidden trade-off of renting that server space is perpetual vendor lock-in and strict daily generation limits. You are also subjected to proprietary safety filters that will frequently block legitimate, safe prompts. Stable Diffusion bypasses all of this. Running the software locally means zero cost per image, ensures absolute privacy, and total freedom from corporate censorship. This bar chart reveals the hidden barrier to entry for open source. While older models require very little VRAM, running the newest SD 3.5 efficiently requires a massive upfront hardware investment, specifically a high-end NVIDIA GPU. Downloading open-weight models also removes corporate oversight. This places the ethical and legal responsibility for what is generated entirely on you. The free open-source model actually costs significant hardware and setup time, while the easy DALL-E workflow extracts a monthly financial toll and sacrifices your creative freedom. Choosing between these systems requires mapping the tools directly to your operational profile. Looking at this decision tree, if your priority is speed, you lack a dedicated GPU, and you need high-fidelity concept art with zero setup, you follow the path to DALL-E Free. The trade-off is accepting the perpetual subscription fee and operating within OpenAI's strict content boundaries. If your priority is exact visual control, training models on proprietary IP, and you own a high-end PC, you follow the second branch to Stable Diffusion. Choosing this route means you must be willing to invest hours into learning complex node-based interfaces and managing large model files locally. Do not buy an expensive gaming PC just to generate a few blog headers. And do not pay a monthly subscription if you are a professional artist who needs exact consistency. Define your primary constraint, time or control, and choose the tool that respects it.